coordinates. Okay, we're going to be studying about stationary points. Okay, a stationary point on the curve, alright, it is what we refer commonly before this, okay, your maximum and minimum, okay. Okay, so there are actually three different types of your stationary points. Currently, what we know would be your maximum and your minimum. Okay, when it comes to a stationary point, the gradient of the tangent would actually be equals to 0. Okay, why would we say that? If you think about your graphs, okay, if you have a U-shaped graph where there's a minimum point, if I want to draw the tangent for this particular point, it will have to be a horizontal line. And a horizontal line would have a gradient of equals to 0. Right? So likewise, if I have a curve with a maximum point, it will also have gradient equals to 0. Okay? So looking at try 1. Okay, we are given the equation of this curve y equals to 3x squared minus 6x plus 1. Okay, for x more than 0 only. And then they actually wanted you to find out what is the derivative. So looking at our derivative, which we're familiar, hopefully we are familiar by now, it will be 6x minus 6. And then in part 2, they want you to find the coordinates of the stationary point. So knowing now that stationary points have gradient, or rather the derivative will be equals to 0. So therefore 6x minus 6 equals to 0. X will be equals to 1. Y will be equals to negative 3 plus 1, negative 2. Okay, so therefore the coordinates will then be 1, negative 2. Okay, so that is how we can find out what is the turning point or the stationary point. Alright. Any questions? The skills that we have learned so far in E-maths, okay, to find out what is the minimum point. Okay, what have we learned so far? How do we find that out in our E-maths? Yeah, 2 ways.
The first chapter that we learned.
Yeah.
I don't know what it's called.
You find the intersect, then you divide by 2.
Very good. Okay, so we find out what is the intersection of the x-axis. Then after that, we find out what is the midpoint. So if this were, for example, 2 and 4, so the x coordinate for this will be 2 plus 4 divided by 2. So that will be 3. Okay, then after that, we can substitute x equals to 3 into here to find out what is the midpoint. Okay, sorry, to find out what is the minimum point. So this is one way. Okay, what is another way that we have learned?
Completing a square.
Completing a square, good. Okay, so another way that we have learned is to complete the square.
Oh my god, I totally forget about
Okay. Right, so now in A-maths, we are looking at the derivative. Okay, but of course, should we differentiate in E-maths? No lah, huh? Okay, there's no necessity to do that, right? So, but of course, you could do exercise working, get a scrap piece of paper from the examiner, okay, do and have a check. Okay, just in case you are not very confident of completing the square, and then you want to check, but you're very confident in doing the differentiation, then you can actually do a check whether your answer is correct or not. Okay, so if you don't know how to completing the square, right, or you are not confident in your process of doing the completing the square, then you get an answer, then you differentiate the function given in your Emacs question, differentiate it, then put it equals to 0, then you do the same method lah.
Oh.
Then you can check what? Yes, Jing Hai. What if what? To what? To find the gradient of what? In what? In Emacs. What did I just say? Don't do Emacs in Emacs already, right? Please just don't okay? Go and learn your Emacs better. Okay? You will still get the marks but it is a bit redundant. Okay? But definitely if it comes to giving you a curve, you are expected to draw your tangent. You cannot just go and differentiate and then find the gradient for me. No. That one surely is not acceptable because the question will tell you, draw a suitable line such that you find the gradient at that point. So you are not answering the question already. So you will not get the mark. Yes, any other questions?
But if you want to check using the dy dx, right, then won't you need the y as well?
Yeah, the question will give you the y what? You need to complete the square of this equation what?
Then, but if you're assuming the square is... Oh, okay.
You understand? Okay? Any questions? Alright, so this one is a simple start, yeah? Okay, so as I was mentioning, there are actually 3 different types of stationary point. Take note that down here I'm saying turning point. Turning point only refers to your maximum and your minimum. Stationary point will refer to maximum, minimum, and also the thing called point of inflection. Okay, so if you were to refer to your textbook on page 1,
Point of inflection, turning point.
point of inflection is not a turning point because it doesn't turn. Okay, if you look at page 401, coincidentally your class,
Yay!
there is this diagram.
Oh shit.
You have a graph that looks something like that. Okay? That's what you can see in page 401. Then after that, there's a y over here. So maximum point, okay, we will see that at this section, this is a turning point itself. We will consider this as a maximum. Okay? Then after that, over here, we will consider this as a minimum point. Okay, a point of inflection, that will actually be here.
Got curve lah.
Okay, yes. So where do you usually see such a thing? Okay, for example, your cubic functions. Okay, y equals to x cubed is a graph that looks like this. So at this point over here, this is your point of inflection.
So the point where the gradient turns to positive.
Okay, so there is actually so this thing itself, okay, whereby there seems to be like a change, alright, but it isn't really a turn. Okay, that is what we call point of inflection. Right? So what we observe is that for maximum point, in this case, we find that the gradients of tangents, okay, the gradients of the tangents over here, this one will actually be dy over dx. It is actually positive, right? Over here, it is negative because downward sloping. Sorry that my tangents are not very accurate. Okay. Then after that, for towards the minimum, this side here it is negative. Over here it is positive. Okay. Whereas for point of inflection, this side it is positive, and then over here it is also positive. So what we're concluding over here is that, okay, for maximum point, your gradient changes from positive to negative. For minimum point, the definition is that your gradient will change from negative to positive. Whereby for point of inflection, okay, there is no change in the sign of your dy over dx. Okay, so let me just write that down. Okay, so just now I was saying maximum and minimum points are what we consider as turning points. And then after that, all these three are considered stationary points. So if you are fearful of using the wrong term, okay, you could just start to use the general word of stationary points. It will cover all three. So it really prevents any of this kind of wrong term usage. Okay, take note that point of inflection, okay, it just says that the derivative has no change in sign. It could be both positive or it can be both negative. Okay, because you can also have your negative cubic curve like that. Right, so there's still a point of inflection here, just that in this case the derivative is negative. Okay, so both sides can be, I'll just write loosely over here. dy over dx more than 0 or dy over dx less than 0. Okay. Any questions? Okay, so with this in mind, I will introduce the first derivative test. The first derivative test is meant to determine whether a stationary point, okay, so in order to determine that it is a stationary point, you will know that dy over dx is equals to 0, okay, but you will need to actually be familiar with all these three things that I've written in red now, okay, to determine whether is it maximum, minimum or point of inflection. Okay, so this is what the purpose of a first derivative test will be. Yes?
Then they question you like, how is point of inflection the gradient?
Oh, how is point of inflection gradient 0? Yeah. Okay, so the way that we will draw the so-called, not really a tangent, okay, we define it, this one, we will define it as having a line like that. Okay, although it's technically not a tangent. Okay, this is how it has been defined that way now. Okay.
Also, it's a part where it changes.
Yeah, there is a change in the way it curves, right? But then it is not a maximum or minimum. So that's why it's a point of inflection.
Axis.
Yeah, for a cubic one. Okay, so the way we so-called draw the tangent would be a horizontal line still. That's why it would actually still fall as a stationary point. Right? Any questions so far? Okay, let me introduce an example. I'll erase this diagram. Okay, let's look at try 2.
Also to test whether the gradient is 0.
Okay, so it says that there's this curve, it has a stationary point at Q. find the coordinates of Q and then also determine the nature of this point. So in order to find the coordinates of this point, okay, since we are told that it is a stationary point, so dy over dx must be equals to 0. So differentiating this function using your chain rule, so your dy over dx is equals to 18x minus 24. Okay, so dy over dx equals to 0 for stationary point. Your x would be 4 over 3. And y is equals to 0. So therefore, the coordinates of Q will be 4 over 3 and 0. Okay, or 1 and 1/3 and 0 also.
What's that?
Okay, so this was what we have done in try 1, whereby we want to know what is the stationary point. Okay, so now the question is asking to determine the nature of this point. So to determine the nature, okay, we will use the first derivative test, right? Which will actually be looking at all these different derivatives. So how do we actually go about doing that? Let me erase this one. So using the first derivative test, please draw a neat table. Okay, since we are looking at the point where x is equals to 4 over 3, okay, we will need to actually look at, just now my graph,